let us discuss vector addition and vector addition from geometrical perspective and analytical perspective. In geometrical, we will discuss triangle law of vector addition, parallelogram law of vector addition, and then also polygon law of vector addition. So what happens in triangle of vector additions, if you are interested to find the resultant of two vectors, then you will have to construct a triangle using these two vectors as the sides of the triangle taken in a head to tail manner, means in a order. Then the resultant of these two vectors will be represented as the other side of the triangle or the closing side of the triangle taken in opposite order. But how it happens? That means if this is a vector A vector, I take it as the A vector. The another vector somewhere here is B vectors. Let us define B vector. Then if I am interested to find the resultant of these two vectors, then I will have to construct a triangle taking these two vectors as the sides of the triangle taken in head to tail manner. That means this is the tail. I will bring the B vector, connect its tail to the head of the first vector. Then I will get somewhere like this way. This way. This is my B vector, let us say. Then the resultant is this one. Resultant vector is this one. Okay. This is my resultant. Okay. This is theta. Theta is the angle between the two vectors. Then the resultant angle is somewhere phi, and the resultant I can write R is equal to A vector plus B vectors. Right? This is OP. Let me take this as Q points. That means in a triangle of vector addition says that if you are interested to find the resultant of two vectors, you have to construct a triangle taking these vectors as the sides of the triangle, and they must be, the sides must be in a head and tail manner. Then the other side of the triangle taken in opposite order represents the resultant vector. This is what the geometrically we can say as that of your triangle law. Similarly, for a case of polygon law, the two vectors must be simultaneously acting at a common point. Then the resultant vector should be the resultant vector of these two commonly acting vectors must be the diagonal passing through the common point of action. How it is there? That means if I have one vector A here, another vector is B here, they are acting somewhere at a common point O, then in that case your resultant vector is nothing but you will have to form a parallelogram. This is a parallelogram. I can say OP, this is Q, I can say this is C. Then the angle between these two vectors is obviously theta, and the resultant angle is phi. I say phi. This is the resultant, that is equal to A vector plus B vectors, and the resultant is the diagonal passing through the common point. That is what the parallelogram law of vector addition says. This is, we can have geometrical method, and coming to that same method we can extrapolate this to find out the polygon law of vector addition also. That means successively, if you have a vector A vector, if you have another vector B vector, if you have another vector C vector, like that, then you can find out the resultant of this A vector as A plus B vectors. Then these two vectors is A plus B plus C vector. Like that, you can find out the, apply successively to find the resultant of these vectors. Now let us see the discussions and prove it in an analytical manner. So to do that, why, let me draw a perpendicular here. Let me name it at N. Let us say. Now pick up these triangles. Now if in the right hand triangle, the first triangle, that is ONQ, here I can have in the right hand triangle ONQ, I can write down OQ square. OQ square is equal to ON square plus NQ square. Right? And this ON is nothing but OP plus PN. So therefore I can write down OP plus PN whole square plus NQ square. Right? Again, I can open it, write OP square plus PN square, and this is 2 OP into PN times plus NQ square. Now if I carefully mark, that is in this triangle, again in the triangle, that is your right angle triangle PNQ. In this right angle triangle PNQ, here I can have, that is PQ square is equal to PN square plus NQ square. So therefore, in place of PN square and NQ square, I can write down PQ square. So OP square plus PQ square plus 2OP and PN. Now again, if you carefully mark, what is this OP? OP is nothing but the A vector, the magnitude of which I can take as A. So therefore it is A square. PQ, what is PQ? PQ is nothing but the B vector, the magnitude of which I can take it B square. Similarly, here OP is twice A magnitude I can write down, and the PN, what is the PN? If I mark carefully, that is PN is nothing but your PQ cos theta. What is PQ? PQ is B mod, so therefore it is B cos theta, right? So in place of PN, I can substitute the value PQ cos theta, which is equal to B mod cos theta, right? And here my OQ, what is my OQ? OQ is nothing but the resultant, so therefore in place of OQ square, I can write down R square, which is equal to A square plus B square plus twice AB cos theta. Therefore, this is the resultant, and I can take out the square root of the right hand side to find the resultant magnitude of the resultant vectors. Now coming to the angle of the resultant vector, which is equal to phi. How to find out? Here the angle, if you select the ONQ triangle, then your tan phi, what is your tan phi? Tan phi is nothing but NQ divided by your ON, and ON, in place of ON I can write down A vector plus PN, so therefore I can write down A plus PN. What is PN again? That is B cos theta, so A plus B cos theta. So therefore in place of NQ I can write down what is NQ. NQ is nothing but that of your B sin theta. NQ is nothing but B sin theta, because your sin theta is NQ by PQ, so therefore your NQ is equal to B sin theta. That means your tan phi is equal to B sin theta by A plus B cos theta, which I can write down, that is theta is equal to tan inverse B sin theta by A plus B cos theta, which is the resultant angle of the resultant vector A plus B making with A vectors. This is how we can find the resultant of two vectors under addition. We can discuss in subsequent class the application of these in further classes. Thank you.